Our lesson today is lesson 12.3. We're back to chapter 12, where we're going to be multiplying and dividing monomials, which are one term, and polynomials, which are different terms. So we're going to have most of it is connected to distributive property. Whenever I multiply, I add exponents. Remember this. Whenever I divide, I subtract exponents. The first example we're going to be talking about is 3x parenthesis 5x plus 6. There's a parenthesis, so I'm going to be distributing. Okay, bring down the 5x and the 6. Bring down your plus sign. What am I distributing? 3x. 3x times 5x, 3x times 6. 3x times 5x, 3 times 5 is 15. X and an x gives me an x to the second power. Plus 3x times 6 is 18x. What do? Can I add them or subtract them? No, that's my answer. Let's look at the second example. Negative 7z plus 1 in parentheses 2z. Sometimes they're going to put for you the number to be distributed outside on the left. Sometimes it's going to be on the right, but the same concept applies. This I'm going to be distributing in here and in here. Bring down what's in my parentheses, negative 7z and a 1. Bring down the plus sign. What am I distributing? 2z times negative z, 7z, 2z times 1. 2 times a negative 7, negative 14. A z and a z gives me a z to the second power. Plus 2z times 1 is actually a 2z. Can I add and subtract them? I can, so they are still the same. That's my answer, and that's what it's going to be. T minus 4 in parentheses, what's outside my parentheses is a negative 5t to the second. What am I distributing? The negative 5t, I'm distributing it into this. Bring down what's in my parentheses, the t and the 4 and the negative sign. What am I distributing? Negative 5t to the second. Negative 5t to the second times t, negative 5t to the second times 4. I start multiplying. Negative 5 times a 1 is a negative 5. T to the second and a t is a t to the third. Minus and minus give me a plus. 5 times 4 is 20. There's no t, so it's t to the second. And this is to the power of 3. This is to the power of 2. I cannot add or subtract them. I can only add or subtract only when they have similar exponents. Again, if I look here, I'm distributing the a to the second into this, into this. Bring down what's in your parentheses. Bring down the sign in the middle. What am I distributing? A to the second. A to the second times a to the second, a to the second times 7a. A to the second and a to the second give me a 2 plus 2, a to the fourth. Minus 7, there's no number out there, I bring down the 7. A to the second and a, which is the power of 1, is 2 plus 1, a to the third. Can I add or subtract them? No, I can't. This is a to the fourth, this is a to the third. I just leave it as it is. Here I have in my parentheses 3 terms. Just the same thing. I don't change anything. If I have 2 terms, if I have 3, if I have only 1, again, it's the distributive property. What am I distributing? 2x to the third. I'm distributing it in here, and in here. I bring down what's in my parentheses, x to the third, 3x, and a 7. I brought them down. There's a minus sign here, and there's a plus sign here. What am I distributing? 2x to the third. 2x to the third times x to the third, 2x to the third times 3x, 2x to the third times 7. I start multiplying. 2 times 1 is a 2. x to the third, and x to the third is x to the sixth minus 2 times 3, 6, x3 and a 1 is x3 plus 1, so it's 6x4 plus 2 times 7 is 14. No more x's except for the x to the third, and that's my answer. Can I add or subtract them? X to the sixth, x to the fourth, x to the third. I cannot add or subtract. This is my final answer for me to know. How many terms do I have in my parentheses? 1, 2, 3. I bring down 3 arrows. 2ab, a, and 4b. I bring down my negative sign. I bring down my plus sign. What am I distributing? Negative ab. So it's negative ab times 2ab, negative ab times a, negative ab times 4b. Now I start multiplying and dividing. Multiplying. Negative and a positive give me a negative. 2, there's no other number. I have a and an a, so it's 1 plus 1, and b 1 plus 1. I continue. Negative and negative give me a positive. I have 2 a's, so it's a 1 plus 1 and a b. Plus and a minus. 4, there's no other number for that. Is there another a? No, I bring it down as it is. How many b's? b 1 plus 1. And now I start adding my exponents. Negative 2, a power 1 plus 1 is 2, b power 1 plus 1 is 2, plus a, again 1 plus 1 is 2 and a b on its own, minus 4, a is on its own, b to the second power. Are they similar? A2, b2. Is it similar to a2b? Nope. Is it similar to ab2? No. So each one is different. A to the second and b to the second is one type. A to the second and b is another type. A and b to the second is a third type. So they're not related. I cannot add or subtract them. Again, I have 3 terms into my parentheses. 1, 2, 3. A to the second, 7c, d, and a 1. What are the signs? A negative and a negative. Now, what am I distributing? 2cd. 2cd times a2. This is a d to the second, I'm sorry. So this is a d to the second. And then 2cd times 7cd and 2cd times 1. I start adding my exponents. 2 times nothing is a 2. The c, is there another c? Nope. I have a d1 and a d to the second, so it's 1 plus 2 minus 2 times 7, 14. I have a c and a c, which is 1 plus 1. I have a d and a d, which is 1 plus 1 again, minus 2 times a 1 is a 2, and I bring down the cd because there are no more variables. Now what do? I start adding my exponents. 2c d to the third minus 14 c to the second d to the second minus 2cd. Let's look at it. C d to the third, c to the second, d to the second, and this is a cd. They're not similar. This is one together, this is another one together, and this is together. They do not look alike, not in any way. So I cannot add or subtract. I leave my answer as it is. Now, number 8, we're going to be dividing. I have 3 terms, and I'm dividing with only 1 term. The first thing, the trick behind this, is I put each term on its own with the same denominator. So first, 6x to the 6th minus 10x to the 4th plus 2x to the 2nd. What am I dividing with? Negative 2x to the 2nd. Put it over negative 2x to the 2nd, over negative 2x to the 2nd, over negative 2x to the 2nd. It doesn't matter how many times I write my denominator. As long as I write it in all the parts, of the terms on top. If I had 2 parts, it's going to be twice. If I have 4 parts, it's going to be 4 times. And now I start dividing. I take the numbers on its own. 6 divided with a -2 is actually a -3. Because I'm dividing, I have to subtract my exponents because they are similar. So it's x 6 minus 2. I continue. Minus and a minus, plus 10 divided by 2 is a 5. Again, I'm subtracting my exponents. 4 minus 2. Plus and a minus give me a minus. 2 divided by 2 is actually a 1. And then x to the second minus 2. Now I start writing my final answer. -3. X 6 minus 2 is x to the 4th. And then I have plus 5. X 4 minus 2 is x to the second. Minus 1. X 2 minus 2 is actually x 0. What does x 0 mean? A 1. So I just leave the 1 as it is. This is my final answer for division. What do? The first thing I do, I write my numerators as splitting them up into parts, and then I give the denominator to every single part as it is. I start off with the numbers. After I divide my numbers, or I simplify them because sometimes I can get a fraction, I start with my numerator, the exponent of my numerator, subtracting it from taking off the denominator from it. 6 minus 2, 4 minus 2, 2 minus 2, and then I give my answer as it is. Okay, again I have 3 terms. The first thing I do, I split up my numerators. Plus 5x to the second minus 25x. What's my denominator? It's 5x. So I put my denominator on every numerator. Okay, and now what do? I start dividing the numbers. 35 divided by 5 is a 7. And here I need to subtract because it's division. X 3 minus 1, because there's a 1 here, that's invisible, plus 5 divided by 5 is a 1. X 2 minus 1, because there's an invisible 1 here, minus, again 25 divided by 5 is a 5, and x 1 minus 1. Now I start writing my answers. 7. X 3 minus 1 is x to the second, plus 1. X 2 minus 1 is actually an x. I don't have to give it an exponent. Minus 5. X 1 minus 1 is actually an x 0, so it becomes a 1. It's invisible, so it's a 5. This is my final answer. The part for division, I split them up. I give every numerator, the denominator, the same denominator, 3, 4, 5 times, and then I start off with the numbers, and then I subtract the exponents of the alike terms. Our last example is again made up of 3 parts. I split them up. This H3 does not have a number, so it's an invisible 1. And I give the denominator to each part. 2H2, 2H2, 2H2. And I start off with the numbers. -6 divided by 2 is actually a -3. H4 minus 2. There's no plus or minus, it's a plus. 1 over 2 I cannot simplify. I leave it as it is. H3 minus 2. Why did I put it as a numerator? Because the 3 is bigger than the denominator. Plus 10 divided by 2 is actually a 5. And then H2 minus 2. I start adding and I start subtracting. -3. H4 minus 2 is an H2. 1 over 2 cannot be simplified. I leave it as it is. h, 3 minus 2 is actually an h, so it's 1h over 2, plus 5h, 2 minus 2 is actually an h, 0, so it's a 1. So this is my final answer. Did you see that sometimes you get fractions, you leave the numerator as it is and the denominator. If you can simplify, do that. If you can't, just leave it as it is. Always remember, multiplying and dividing monomials and polynomials, you're going to have 2, 3, 4 terms for you to distribute and multiply, or you're going to have 3 terms to divide with. Whenever you're multiplying, you're adding exponents. Whenever you're dividing, you're subtracting exponents of the similar type of variables. Always remember, simplify when you're dividing as much as you can. Sometimes you can't simplify, you just leave your fraction as it is. When you're multiplying, make sure the last step there are no similar terms, or else you have to add them. But here in all this lesson, there is nothing to be added or subtracted at the end. Always remember, the most important thing is the work you do with the exponents, either it's in multiplication or division.